last week. Last week, I introduced the concept of an ionic compound and a covalent molecule, or also known as a molecular compound. Ionic compounds must have a metal. If there is no metal, then it is a molecular compound. You have to be able to differentiate whether you're working with an ionic compound or a molecular compound, folks. Because if you can't differentiate between the two, then you can't possibly figure out how to name them, because the naming scheme is different depending upon whether it is a ionic compound or a molecular compound. Now, when we develop an ionic compound, ionic compounds consist of a cation and an anion. The number of cations and the number of anions that are attracted to one another electrostatically is dependent upon how many are needed in order to obtain charge neutrality, because ionic compounds must be charge neutral. So at the end of lecture last week, we looked at a variety of compounds and we developed the formula of the ionic compound based off of the ions themselves. And with like cobalt hydroxide, we said, okay, it contains cobalt 2, and for some reason my pen is not writing. There we go. We had cobalt 2 and hydroxide. Hydroxide is one of the polyatomic ions that you will have to know. We took the magnitude of the charge and we dropped it on the opposing ion. So on our cobalt, we dropped a 1. Our hydroxide, we dropped a 2. When we drop a 2, what it means is we have 2 units of hydroxide. So we place the polyatomic ion in parentheses with the quantity as a subscript outside. So the formula for this compound would be shown as CO, open parentheses, OH, close parentheses, 2. Because when a subscript is not shown, it means that there's one of them. Now, from a formula standpoint, what this means is that there is one cobalt atom. There are 2 oxygens and 2 hydrogens. Again, that is because of that 2 outside the parentheses, saying that there are 2 hydroxide units. Now, I am not going to give you the ions to start with. Instead, you're going to get the names of the compounds. So we need to talk about naming compounds. And this is where I finished on Thursday of last week, is with this particular slide. With ionic compounds, the first thing you have to determine is whether the metal is one that forms only one type of ion, or whether the metal can form multiple types of ions. As a reminder, the ones that form only one type of ion is group 1, which forms only a +1. Group 2, which forms only a +2. Silver, which forms only a +1. Zinc and cadmium, which only form a +2. And aluminum, gallium, and indium, which only form a +3. Those are the metals that you have to know the charges of. All other metals, we are going to assume that they can form more than one type of ion. Now that's important because if it is one of those metals that I just listed, group 1, group 2, silver, cadmium, zinc, aluminum, gallium, and indium, then we're going to name the cation. Basically, we're going to name the metal, and we're going to name the anion. If it's an anion of an element, it's going to get the ending IDE. Whereas if it's a polyatomic anion, there are 3 polyatomic ions that get the ending IDE, but the majority of them get the ending ATE or ITE. Now, if it's a metal that can form more than one type of charge, you name the metal, but then you have to tell me what charge it is. And we describe the charge as a Roman numeral in parentheses following the name of the metal. And then we name the anion. And on Thursday, I gave you the Roman numerals that we use, which is 1 through 7. I can't think of any metals that form a cation charge greater than 7. And in fact, very few metals form a cation charge of 7 because it takes a whole lot of energy to do that. So again, these are the metals I am asking you to memorize as having only one charge associated with them. All other metals, we're going to assume, have more than one charge associated with them. And that is actually a fairly accurate statement, even though they say, okay, zirconium only forms a +4 on this table. That is not entirely true. Zirconium's favorite charge is a +4, but it does have other charges that aren't shown. What this table really is showing is what are all the favorite charges of those particular metals. And iron, you find at both of these frequently. So that's why you see more than one. But I'm asking you to memorize the stair step and group 1, group 2. Those are going to be your metals that have only one charge, so we just give the name. If it's not one of those metals, you're going to have to give me the name and you're going to have to tell me the charge on the metal. Now for your anions, group 17 nonmetals and metalloids form a -1 anion. Group 16 nonmetals and metalloids form a -2 anion. And group 15 nonmetals and metalloids form a -3 anion. When we name those particular ions, we take the name of the nonmetal and we use just the base of that name. and then we give it the ending IDE. So fluorine is the element F. But if you have an anion of fluorine that has a -1 charge, then we're going to take the base of the name, fluor, and we're going to add the ending IDE, so it becomes fluoride as an anion. Iodine. Iodine itself is I, but if you have I minus, then you take the base, which is iode, and you replace the ending with IDE, so it becomes iodide. Oxygen is oxide, sulfur, sulfide, nitrogen, nitride. Folks, I want to drive home the ending IDE. IDE, except on 3 occasions, means that it's an anion of its element. Those 3 occasions are hydroxide, which we saw in the previous example, cyanide, which is Cn minus, and peroxide, which is O2, O subscript 2, 2 minus. Those are the only 3 I's that are not going to be an anion of an element. Speaking of those 3, those are polyatomic ions. Here is the peroxide and the cyanide and the hydroxide I talked about. But other than those 3 and ammonium, you will notice that the majority of these end in ATE or ITE. While I gave you a huge list of polyatomic ions that you may encounter on the optional homework, for an exam, those are the polyatomic ions you must know. So if you're one that likes to make flashcards, you can take a photograph of this. Or you can just grab it out of the in-class presentations. But these are the polyatomics you must know. Notice that other than ammonium, which is NH4+, all of the polyatomic ions you must know are anions. So let's look at all the, yes.
Is there any particular tool that we can use to deal with the manganese and chromium ions here, that we don't try to break those down into ions themselves? That they wouldn't be ionic compounds?
The answer to that question . So let me make sure I'm understanding the question. We have, for example, permanganate. You're asking, why doesn't that break down into a cation and an anion?
It's a metal.
It is a metal. The answer comes down to the structure of what permanganate looks like. And the manganese in this particular case is not a fully charged species. So no, I don't have an answer for you as far as why you don't break permanganate down into manganese and the oxygen. There's just, now chromate and permanganate and dichromate are the most common. I'm not gonna say the only, but they are the most common polyatomic ions that actually have a metal. But most of your polyatomics don't, as you can see. But no, I don't have an answer. Okay, so let's look at this in action. What are you gonna have to do? Well, let's name NaCl. Step number 1. When naming is what type of compound is this? Ionic or molecular? It's ionic. It's ionic because it has a metal. Therefore, we go back to this. So our compound was sodium chloride. Which of these categories does the sodium cation fit into? It's the one that has only one type of ion. That's the second step. Knowing that it has only one type of ion. Then we know we're going to name the cation and we're going to name the anion. So this compound, the second step was to know that it had only one type of ion. So we name the metal, which is sodium, and we name the anion, which is chloride. What we're using, folks, is called IUPAC naming. And I bring up that term because you're going to encounter IUPAC naming, and then some molecules have some traditional naming or old school naming. IUPAC is an organization over in Switzerland that basically has developed a method to name compounds so that everybody in the entire world will know what that compound is by how we're naming it. But this, folks, is sodium chloride. Let's look at the next one. Step 1, is it ionic or is it molecular? Well, it's ionic because that's where I'm at. What type of cation are we dealing with? Only one type of ion because it's in group 2. So we name the metal, which will be barium, and we name the anion, which is oxide. Again, I know it's an IDE because it's an anion of an element. And all anions of an element end in IDE. Let's look at the next example. Is it ionic or molecular? It's ionic because it contains a metal. Are we looking at one type of charge or more than one type of charge? Cobalt has more than one type of charge. That last statement tells me I'm going to need a Roman numeral. Well, I got to be able to figure out those Roman numerals, and we haven't talked about that just yet. How do you know what the charge on the metal is? Okay. The fact is You can always predict the charge on the metal because the charge on the anion never changes. We can predict the charge on the metal because the charge on the anion never changes. If I have sulfur, sulfur's in group 16. Group 16 is a -2. Therefore, that's a -2. I have one cobalt whose charge I need a Roman numeral for, which I'm going to call X. I have two sulfurs times the -2, which is a -4. And I said that ionic compounds must be charge neutral, meaning they must equal 0. So X minus 4 is equal to 0. X has to equal 4. So therefore, the Roman numeral on this cobalt is IV for 4. And so it's cobalt 4 sulfide. Questions? Okay, let's look at another example. Ionic or molecular? Again, it's ionic. I mean, that's where we're at today, but still, that should be always your first question. Now, one type of charge or more than one type of charge? One type of charge. So we are simply going to name the metal, which is zinc, and we are going to name the anion. This anion is one you're going to need to get to know. It is the anion acetate. So that is zinc acetate. Let's look at another example. Okay, I'm going to start. It's ionic. Now, one type of charge or more than one type of charge? More than one. It's not one of those that I asked you to memorize. Therefore, you need a Roman numeral. Okay. How do we get the Roman numeral? Well, the fact is anion charges never change. SO4 is the polyatomic anion sulfate. Sulfate always carries a -2 charge. We need to figure out what gold's charge is. We have 2 gold times X. We have 3 sulfates times a -2 to make a -6, and ionic compounds must be charge neutral. 2x, therefore, equals 6. X equals 3. So the Roman numeral that I'm going to label my gold as is going to be gold 3, and then sulfate, which is the polyatomic ion. Yes.
Or, compounds like this one and then or like any of these that have multiple, diatomics like that, would you not say like trisulfate or for the last one, like, or for the cobalt sulfides, like disulfide?
Excellent question. Because it is a common mistake. With ionic compounds, we rarely use di, tri, tetra, and so on and so forth. Ionic compounds, you may see it written that way, but IUPAC naming does not do that with ionic compounds. That is one way we're going to be able to distinguish an ionic compound from a molecular compound. So I'm not going to say you're not ever going to see it, because you will see it on the internet, but it's not IUPAC naming if they use di and tri.
I suppose since these dissociate in solution, they don't have that combination, they wouldn't be dis or tris. They're just separate.
Well, not all of these, as we will learn, dissociate in solution, but you're right. If they dissociate, they're no longer, they're just ions floating around in solution, so it wouldn't be di and tri. But it's the fact that we're using IUPAC naming, that you don't use di, tri, tetra, and so on and so forth with ionic compounds. How about this one? Okay, well, it is ionic. One charge or more than one? One charge, because it's in group 2. So we name the metal, which this is strontium. And we name the polyatomic ion. This one you can name a couple of different ways, but the IUPAC naming is going to be as hydrogen sulfate. How about this one? I want to see if you can name this one. Okay, we know chrome, it's ionic. We know it has more than one charge. What's the charge? It is 6. I put this one in every single time. And I'll explain why in a moment. Again, oxygen's a -2. Chromium, I don't know, but there's one of them. So 1x minus 6 is equal to 0. So x has to equal 6. So this is chromium 6 oxide. The reason I put this one in there is because a lot of students have been taught, okay, just, when we, let me scroll back. Let's see if I can get to it this way, actually. A lot of students, well, even we have been doing this cross drop and simplify. And a lot of students want to just backtrack that cross drop. You can't backtrack the cross drop because of the word simplify. Ionic compounds are always in the simplest whole number ratio possible. So you can't simply backtrack your cross drop because you may have had to simplify it. So in that previous example, I couldn't, I put it in there because I want you to be careful. You will not take and go, okay, so O3CR, that had to go here and that had to go there. It doesn't work that way. You can't backtrack because of the word simplify. Okay, so you're going to have to name ionic compounds. You're also going to have to get the formula of the ionic compounds from the names of the ionic compounds. Now, getting the formula of the ionic compounds from the names of the ionic compounds, the big challenge is knowing your polyatomics. Because otherwise, it's a matter of translating what's up there. So magnesium chloride. Magnesium is in group 2. It's always a what charge? +2. Chloride. The ending IDE tells me it's an element. I look over and chlorine is in group 17. Group 17 is always a -1. So I translated the name. Then I crossed, dropped, and simplified. So magnesium chloride is MgCl2. Lead 4 oxide. This would be named as lead 4 oxide. I would take and translate the name. So lead 4 gives me Pb4 plus. Oxide, the ending IDE tells me that it's an anion of an element. So that's where the O2 minus comes from. You cross, drop, and simplify. So lead 4 oxide is PbO2. Let's talk about aluminum nitrate. Aluminum. Aluminum is what charge? Aluminum is always a +3. Nitrate, whoops. The ending ATE tells me it's a polyatomic. All ATEs and ITEs are polyatomics. It's the polyatomic of NO3 minus 1. You're then going, so I've translated the name. Now I'm going to cross, drop, and if need be, simplify. So on the aluminum, we're going to put a 1. On the nitrate, we're going to put a 3. Since I need more than one polyatomic, the polyatomic goes in parentheses with the quantity needed as a subscript. Because this literally says I need 3 nitrate units for every 1 aluminum unit. Do calcium bromide. Calcium is in group 2. Group 2 is a +2. Bromide, the ending IDE tells me that it's an anion of an element of bromine. Bromine's in group 17, so that means it's a -1. Once you've translated, you're going to cross, drop, and if need be, simplify. So on calcium, we're placing a 1. On bromine, we're placing a 2. So it's CaBr2. Lead 2 oxide, what is its formula? Lead is Pb. Because Pb is not one of the ones you were told to memorize. It means that it can have more than one charge, and that's why that charge is given to you as a Roman numeral in parentheses. So it's Pb2 plus. The ending IDE stands for an anion of an element. Oxygen's in group 16. Therefore, it has a -2 charge. We cross, drop, we get Pb2O2, but we must simplify. So it's PbO. Okay, folks. Let's get down to the memory work. Because you need to start memorizing for the next test. Because I am going to add a lot to that memory work. So Step number one, memorize the elements that always have one charge. Group one is a +1, always. Group two is a +2, always. Silver is a +1. Zinc and cadmium are a +2, and aluminum, gallium, and indium are a +3. Start memorizing your anions of elements. For group 17 nonmetals and metalloids, it's a -1. For group 16 nonmetals and metalloids, it's a -2. For group 15 nonmetals and metalloids, it is a -3. You must know these. You must be able to basically look at the periodic table, because that's all you're going to be given, and know those. And you need to start memorizing that list of polyatomic ions. You're expected to know those. Process. On what I did today, on page 1 of the packet I gave you last week, all we have done is the ionic compounds, and I have a few extra packets up here because I had some people not here. But all we've done is the very top piece, which is naming ionic compounds. On Tuesday, we're doing the rest of this, which is naming covalent molecules and acids. On page, well, technically, the second page of the document, we've been focused on the left-hand side of this flow chart, which is determining ionic compounds and how to name them. On Tuesday, we're going to focus on the right-hand side of this chart, which, as you can tell, is a lot more complex. On the back page, we have been focused again on the left-hand side of this table, which is a flow chart on how to how to get the formula. We'll be working on the right-hand side on Tuesday. This huge monster of a list I gave you of polyatomic ions and all. You don't have to memorize all of these. Part of these are given to you because you may encounter them on active or the optional homework. But I'm only asking you polyatomic ion-wise to memorize these. I will stick to these on an exam. Any questions about naming ionic compounds? So Monday, we will continue the Lewis Structure Lab. Remember, every single person must turn in their own lab on this one. It is not done by groups. It is done done by the individual because everybody needs to practice it desperately. Because it will be on the next exam. The other things that will be due on Tuesday, there will be 5 Ed Puzzle videos. I will make sure that those get uploaded immediately. And there will be the homework and the active quiz, which will get uploaded fairly quickly too. I will make sure those 3 things go up first, and then I'll upload everything else. That way, whenever you need to get started on those, you can. Remember, because and I'm saying this because I know some people don't like videos. Remember, this is one set of videos you have to watch. Is the Ed Puzzle videos. You have to watch them. They're a lab grade. It's either that or you're dropping that lab grade. And it's a pretty easy lab grade, relatively speaking. Question. Okay, I will see you on Tuesday.
I wanted to ask you, I was looking at my exam and there's just some things I wanted to talk about. If you happen to know, you could be available like for like office hours.
I mean, I'm gonna be in my office from now until 2:30.
Okay.
So I can do it anytime before 2:30. Otherwise, I will be in my office next Tuesday. From 11 till 12:30. But those are my only, besides my office hours, which is 8 to 9.
Thank you. I just wanted to, I'll see if I can make it later if that's okay.
That's fine.
Thank you.
You too.
Can you explain why I'm wrong on this one?
On this one,
Yeah.
because fluoride means that you've added oh, that's a 6. It looked like a 5. You're not wrong. It was because I read it as a 5 instead of a 6.
Okay.
So I will give you back your 5 points.
Okay, thank you.
Oh, I don't remember. I'm just confused if this is supposed to be 1, right? Or the angular should have been 1. And the radial 2.
Because I did like the optional homework and I think, I don't know if that's the same thing.
I reversed them.
Oh. There.
That's.
Thank you.
Mhm.
Well, when do you have like free time? Because I know that you said you're going to record the video. But I wanna know like what I keep doing wrong. Like the first exam I got a 70 out of 50. This one I got an 83.
You know, the
5 out of 50, and I keep wondering like what I'm doing wrong. This one I start studying like 5 days before. I came to your office, I go to essay, like still trying to figure out what I'm doing wrong. And I do the optional homework.
I would say on this one, it is more,